Recorded as rolling. Welcome to Tuesday. So we're going to do a Kahoot today on circuits. Now, the questions that you guys can see, these multiple choice conceptual questions, a lot of these are probably going to pop up on the final exam, which we're getting pretty close to. So speak at starting preparation for that. Actually, I wanted to fit in two, but it's too tight to fit earlier. So I think what we'll do is just do this one Kahoot, and then we'll have a few minutes at the end of class. And do you guys remember how recently I gave you guys time in groups to finish these last Kirchhoff table waterfall models and also these few circuits down here? Okay. Now, a lot of you guys turned these in, but not everybody did. So if you have extra questions about those, or if you need to help each other out, then we should have a few minutes at the end of class. But a lot of these conceptual questions on this Kahoot that we're about to do might help you with those too. Okay. And then tomorrow I have a lab lineup for you guys. Okay. Also, before we hit that Kahoot, let me go over some things that help you guys out with some of these. So do you guys remember Kirchhoff's rules? Well, there was a loop rule and a junction rule, but this is like a modified version. Okay. So how does current flow and voltage drop across resistors either in series or in parallel? So let's start with series. Series, one after another, sequential. The current is the same everywhere, right? So there's just one street for the traffic to flow on, right? So the same number of amps everywhere. Okay. They can be different resistances, but still same current, same number of amps everywhere. But the voltage drops a little bit at a time. In fact, it drops in stages, and the amount it drops is proportional to each resistor. So if this is like 3 ohms and 7 ohms, this would be 30% of the voltage drop, and the other 70% of the voltage drop. And when I had you guys do these waterfall models, that is shown in the height of the waterfall. Right. So like if I have 3 different resistors, my resistor C is the most number of ohms. So the most number of volts drop. Right. So like 12-volt battery drops 6 volts and then 4 volts and then 2 volts because there are different numbers of resistances. Right. So that is series. Right. Then let's flip over and look at parallel. Again, a bunch of Kahoot questions about pop up on these and could also help you out with what you've been doing the last few days. Okay. So parallel, this is where see the current would split, right? But the voltage drop is the same across each resistor. So like from this node to this node, remember voltage or voltage difference, that's sort of analogous to like the height of a cliff for your waterfall model. So like in this last example, I have a bunch of resistors in parallel, like side by side, see the current splits, the separate waterfalls. Okay. Now we might have a thin waterfall and a thick waterfall for representing different number of amps that are flowing, but they're all the same height. So like if this battery pumps up like 12 volts, it's like a pump that pumps up 12 meters. All my waterfalls side by side have same height fall, like same voltage drop. Now maybe there are different resistances, and that's okay, right? Different numbers of ohms, still the same voltage drop, right? That's what that one says. And then the current split. How does the current split? Now this one that maybe you have to think the deepest on, but it makes sense if you think about it. That more current wants to flow along the path of least resistance. So for example, if this is like 3 ohms versus 7 ohms, do you think that 70% of the current wants to go through 3 ohms and the other 30% of the current wants to go through 7 ohms, right? That's exactly what this says. The current through resistor A is proportional to resistor B. Right? Is it, remember that? Right. So there you go. That is a recap of some of those. Okay, let's switch over to one more thing. Near the end of this Kahoot, there's going to be some questions as to like thick filaments versus thin filaments, which is going to be related to a lab tomorrow. So let me introduce this idea. Tomorrow, I'll set you guys up with some Play-Doh and break out those cell phone chargers again. Do you guys know that Play-Doh can actually conduct electricity, just like a copper wire? Right? No, it's not as conductive. It has more resistivity. And that's what we have you guys measure tomorrow. So you guys set up a Play-Doh cylinder, run some electricity through it, say, I wonder how much resistance there is. I've got a formula for it right here. So think about this ahead of time. So the resistance in ohms, right, what was it equal to? Well, do you guys know it would be proportional to the length? Like if you double this length, do you guys think you get double the resistance, right? This is twice as far for electricity to go through. That's why you multiply by L, right? You can also multiply by Greek letter rho in this context represents resistivity. That's a material property. So copper has a resistivity, aluminum has resistivity, Play-Doh has a resistivity. Might figure out tomorrow. Okay. And then cross-sectional area. Right, now this one, you guys thinking deeply about this one? Guys, what would be easier for electricity to flow through? Through a little skinny wire or through a big fat wire? What's easier for electricity to flow through? How many think the big fat wire is easier for electricity to flow through? right? That kind of makes sense. Okay, that's why the resistance is inversely proportional to the area. Because if it's a huge cross-sectional area, if you divide by a huge number, that would give you a very small resistance. Right? Whereas if it's a little skinny wire, then that you'd be divided by a little tiny number, that would give you a very large resistance. That's why the inverse weight shift. Okay, guess that? So there's a couple of Kahoot questions here at the end of this one where that will pop up. All right, you guys ready to tackle these conceptual questions that somebody's gonna show up on your final exam? Switch over and do this.